There is not a single machine learning topic more widely discussed, important to understand, fundamental than overfitting and underfitting. But I don't like complex explanations, so let's try something different. First, a good analogy. Second, pictures. Lots of pictures. These are learning curves. And by the way, hey, me from the future here, including the haircut. If you're looking for something you can learn over a weekend, take a look into plotting and interpreting learning curves. That's a crucial skill you can build really quick that will be fundamental for you. Let's get back to the video. Finally, I'll show you the learning curves of two models, each having a specific problem, something that happens every day. So to get this started, think about a school, a teacher, a set of questions you must study for every exam. At the end of the year, the teacher publishes this chart. It shows the number of mistakes students made in relation to how long they had to study. The longer the students prepare, the better they do. That makes sense. Every teacher out there wants their students to learn the material. They don't want students to optimize for the exam. They want to build knowledge that will later generalize to situations they'll see outside the classroom. We can connect this idea with the way we train models in machine learning. Same principles apply. We want machine learning models to learn and generalize what they know to solve samples outside the training dataset. A model that doesn't learn or can't generalize to new data is a useless model. We use two terms to refer to these models: underfitting if a model didn't learn, and overfitting if a model doesn't generalize to unseen samples. Both cases lead to useless models. Fortunately, there are many different ways to deal with underfitting and overfitting. But before we can do anything, we need to identify them. So let's look at this chart. Very similar to the first one. Instead of mistakes, we have the model's loss. Similar concept. The fewer mistakes the model makes, the lower the loss is going to be. And that's what we want. Instead of time, here we talk about epochs, which are the number of iterations we spend training this model. We call this a learning curve. They're crucial for diagnosing underfitting and overfitting in machine learning models. I want you to notice something important in this chart. This is the training loss of the model. We're measuring the model's learning ability on the same data we use to train it. Going back to the students analogy, imagine the teacher using the same questions they discussed in class to evaluate students during the exam. Presumably, students could memorize the answers and do great. This model has every possible advantage to do well, and yet the loss is not good. You know why? Here is the first inside of this video. A high training loss indicates the model doesn't fit the data correctly. We call this underfitting. Here is a different story. The training loss here is low, so we know this model is not underfitting. But can we say this is a good model? Remember, this is the training loss. Similar to the teacher testing students on the same questions they saw during class. If those students aced the exam, can we say they learned the material? No, we cannot. Maybe they just memorized every answer and didn't learn anything. We need more information to decide whether this is a good model. Every teacher will create an exam with different questions from the ones students saw. We can use the same idea and evaluate the model on a different data set. We now have two learning curves, one training loss and one testing loss. The testing loss here is high. Students did well on the questions they knew beforehand, but did horrible on the new questions. So this is not a good model. And here is the second insight. A high testing loss indicates the model doesn't generalize well. Whenever this happens, we say the model is overfitting. Okay, got this. Here are good looking curves. Low training loss, it means our model learns the training data well. Low testing loss, it means our model generalizes to unseen data. This is a well-fit model. No underfitting, no overfitting. This is what we want to see. Remember, I told you about two separate specific situations I wanted to show you. Here's the first one. These curves are decreasing. It looks like things are fine, but notice the gap between them. This happens whenever the training data set is insufficient sufficient for the model to do well on the testing set. For example, there might be some differences between the training and the testing data, or the training data set might not be large enough. This happens all the time. Main takeaway, you want the gap to be small. Adding more data to your training set might be an option. Ensuring that training and testing come from the same distribution is also a good idea. Either way, whenever this happens, understand there's still a lot of potential to improve a model like this. Final plot. This is the second situation I wanted to show you. A couple things happen here. First, up to this point, the training and testing losses decrease. That is good. Then suddenly, the testing loss starts increasing. Up to this point, the model is well fit. But right when this happens, it starts overfitting. It is memorizing the training data and it is not generalizing anymore. Main takeaway, we train the model for too long. A simple technique to fix this issue is early stopping. You'll see a link up here and in the description below where I cover how early stopping works. In short, we want to stop training right before the model overfits. Keep in mind, these are just a few examples of learning curves you can use to diagnose your models. 3 things you need to remember. First, underfitting and overfitting are the main problems you'll face when training models. Get ready because you'll hear plenty about them. Second, a picture is worth 1,000 words. Make sure you're comfortable plotting and interpreting learning curves. And third, you shouldn't worry about learning curves until you watch this video here, where I share some of the most important advice that has helped me over the years. And this is it for today. As always, I'll see you in the next one.